Hello, my dear students. Today we are going to discuss chapter 5. We are going to continue our discussion on aliphatic acids and their chemical reactions, and we are going to discuss the aromatic acids, the nomenclature and physical properties and their chemical properties and the chemical reactions inside it. So let us start. My dear student, we are going to discuss the reactions specific to the hydroxyl group of aliphatic acids. The ester formation reaction. Aliphatic acids react with alcohols in the presence of concentrated sulfuric acid forming ester and water. As the equation proceeds on the screen, the aliphatic acid, which has general molecular formula RCOOH plus alcohol ROH, that molecular formula of alcohol, in the presence of concentrated sulfuric acid, it gives ester RCOOR and water molecule is produced. My dear student, we can define the esterification reaction as the reaction where the acid reacts with alcohol giving ester and water in the presence of dehydrating agent as sulfuric acid. So, acetic acid reacts with ethanol in the presence of concentrated sulfuric acid forming ester named ethyl acetate ester and water is produced. As the equation proceeds on the screen, acetic acid reacts with ethanol giving ethyl acetate ester in the presence of concentrated sulfuric acid and water is produced. Now we are going to discuss the reactions specific to the carboxylic group. Carboxylic acids are reduced by hydrogen in the presence of copper chromate at 200 degrees Celsius. My dear student, this reduction reaction is the opposite reaction to oxidation of alcohol. So, the acetic acid, when it is reduced by reaction with hydrogen in the presence of copper chromate at 200 degrees Celsius, it gives ethanol and water is produced. Now, we are going to discuss the detection of the acetic acid. The acidity test. When the acetic acid is added to sodium carbonate or sodium bicarbonate, effervescence occurs and releasing carbon dioxide gas, which turbid the lime water. As shown, my dear student, on the screen, the powder of sodium carbonate or sodium bicarbonate is put in the beaker, and then we are going to add the acetic acid or any aliphatic acid. On it, we find that effervescence occurs due to the releasing of carbon dioxide gas and indicating that acid is added to the carbonate or bicarbonate salt. As the equation proceeds on the screen, my dear student, the acetic acid reacts with sodium carbonate giving sodium acetate, and the carbon dioxide gas is given out causing effervescence and water is produced. And we can test the carbon dioxide gas produced by passing over lime water. It will be turbid as formation of white precipitate of calcium carbonate and water is produced. The second type of testing acids is the ester formation test. Acids react with alcohol to form esters, which are characterized by pleasant odor, and they are responsible for the flavor of most of fruits according to the kind of alcohol and the acid used in the reaction. Now, my dear students, we are going to discuss the aromatic acids. Aromatic acids contain one or more carboxylic group attached to the benzene ring. The monobasic acids Here, as shown on the screen, benzoic acid, the benzene ring attached to one carboxylic group, so it ionizes, giving positive hydrogen ion only. While the dibasic aromatic acid here, as shown on the screen, the benzene ring attached to two carboxylic group on the two adjacent carbon atom, we call it phenolic acid. The hydroxy aromatic acids, that the benzene ring as shown on the screen attached to hydroxyl group and the carboxylic group, and its name is called salicylic acid and has IUPAC name 2-hydroxy benzoic acid. Now the preparation of the aromatic acids. By catalytic oxidation reaction, the benzoic acid can be prepared or obtained commercially by catalytic oxidation of toluene in the atmospheric air at 400 degrees Celsius and in the presence of vanadium pentoxide. As the equation proceeds on the screen, 2 molecules of toluene plus 3 moles of oxygen in the presence of vanadium pentoxide at 400 degrees Celsius, it gives benzoic acid releasing 2 molecules of water. Now we are going to discuss the physical properties. Aromatic acids are stronger and less soluble in water and less volatile than aliphatic acids. The chemical properties of aromatic acids. Their reaction resembles that of aliphatic acids. At the formation of salts, on reacting with metals or with their oxides or with their hydroxides or carbonates. The reaction with metals. With magnesium metal, benzoic acid reacts with magnesium, forming magnesium benzoate, releasing hydrogen gas. As shown on the screen, my dear student, on adding the magnesium with the benzoic acid, the magnesium replaces the hydrogen, releasing the hydrogen gas, and so it can be tested that it burns with pop sound, as shown on the screen. The reaction with oxides or hydroxides. With copper oxide, benzoic acid reacts with copper oxide, giving copper acetate, and water is produced. With sodium hydroxide. Here, benzoic acid reacts with sodium hydroxide, giving sodium benzoate, and water is produced. And my dear student, you remember, the preparation of benzene in lab is done by using sodium benzoate on reaction with soda lime to forming benzene. Now, the reaction with carbonates or bicarbonates. Here, the reaction with sodium carbonate, the benzoic acid reacts with sodium carbonate, giving sodium benzoate, and the carbon dioxide gas evolves and water also is produced. So we can see the effervescence occur by the releasing of carbon dioxide gas. Also with sodium bicarbonate, the benzoic acid reacts with sodium bicarbonate, giving sodium benzoate and releasing also carbon dioxide gas and water. And this reaction can be considered for testing acids. Now, the formation of esters on reacting with alcohol, or we can say esterification reaction. As the equation proceeds on the screen, benzoic acid reacts with ethanol in the presence of dry hydrogen chloride gas. It forms ethyl benzoate ester and water is produced. My dear student, we can't use sulfuric acid as it reacts with the benzene ring. So we use only here dry HCl as dehydrating agent. Now we are going to discuss the organic acids in our life. The formic acid, HCOOH. It is acid which is secreted by ants to defend themselves. As shown on the screen, we can get the formic acid from using ants by distillation of the ants, and this formic acid can be used in dyes and insecticides, as perfumes, and in drugs. And the formic acid here named due to the production of the acid from ants, or formica in Latin. My dear student, now we are going to discuss the acetic acid that has structure formula CH3COOH, which is pure 100%. It is colorless liquid, corrosive to skin, and has pungent odor. It freezes at 16 degrees Celsius, forming solid substances as ice. Therefore, it is called glacial acetic acid. The acetic acid 4% is used as vinegar in homes. It is considered as starting material for the synthesis of many organic products. For example, synthetic silk, dyes, insecticides, and food additives. Now we are going to discuss the benzoic acid that has structure formula C6H5COOH. It is sparingly soluble in water. It is converted to its sodium or potassium salts to become soluble in water and easily absorbed in the human body. So we have good reason in this point. Sodium benzoate 0.1% is used as preservative substance for food. The reason for that, it prevents the growth of fungi on food. Now we are going to discuss citric acid that has molecular formula C6H8O7. My dear student, as shown on the screen, this is the structure formula of citric acid that has 3 carboxyl group, so it is tri-basic aliphatic acid. My dear student, it is found in fruits and its percent is 5 till 7% in lemon and 1% in orange. So we have good reason in this point. Citric acid prevents the growth of bacteria in food. The reason for that, it decreases their pH. Another good reason in this point, citric acid is added to frozen fruits. The reason for that is to retain their color and taste. Now we are going to discuss lactic acid that has molecular formula C3H6O3. As shown on the screen, this is the structure formula of lactic acid. We can name it isoprene name by 2-hydroxypropanoic acid. It is found in milk as a result of the effect of enzymes that secreted by certain kind of bacteria on milk sugar. It is generated in human body as a result of hard effort and causes constriction of muscles. Now we are going to discuss ascorbic acid, which is vitamin C. The human body needs vitamin C in small quantities. It is found in acidic substances like fruits, vegetables, and green pepper. It is hydrolyzed by heat and the effect of air. The lack of vitamin C leads to what? The infection by scorbut disease. The decrease in the biological function in the human body. Now we are going to discuss salicylic acid. And we have good reason in this point. Salicylic acid is used in the manufacture of cosmetics specific to the skin. The reason for that, it makes the skin more soft and protect it against sun rays. My dear student, salicylic acid is used from 1829 in the treatment of cold, disease, and headache before using aspirin. And we have give reason in this point. Salicylic acid is not used to treat cold disease because it causes bleeding of the stomach. Now we are going to discuss the amino acids or organic acid derivatives. It is formed by replacing one hydrogen atom in the alkyl group of the acid molecule by an amino group NH2 group. The simplest member of amino acid is glycine, which is also named amino acetic acid. As shown on the screen, in acetic acid replacing the amino group by the hydrogen, we can remove the hydrogen and replace the amino group, forming the glycine. My dear students, amino acids are numerous in nature, but only 20 of them exist in natural protein. The amino acids which form proteins are one of the alpha amino type. As shown on the screen, the carbon that attached to the carboxylic group is called alpha carbon, and so it is attached to the amino group, so we can say its name is alpha amino acetic acid. Now here proteins are considered as polymers of amino acids. For example, insulin is a protein molecule. Its molecular mass is 6,000 and consists of 51 molecules for 16 amino acids. My dear students, the molecular mass of some protein molecules reaches 1 million in some complicated enzymes. Now we are going to discuss questions. First type of question, write the scientific term. Organic compounds having one carboxylic group or more. If you think about it, it will be carboxylic acid. Reaction of acid with alcohol in the presence of concentrated sulfuric acid. If you think about it, yes, it will be ester formation or esterification reaction. The reaction of carboxylic acid with sodium carbonate or sodium bicarbonate, yes, if you think about it, it will be acidity test. Natural polymers arise from the condensation of alpha amino acid with each other. If you think about it, yes, it will be proteins. Next point, the number of carboxylic groups in an organic acid. If you think about it, yes, it will be basicity of acids. Next point, polymers of amino acid. If you think about it, yes, it will be proteins. The next type of questions is choose the correct answer. The carboxyl group is composed of what groups? Is it hydroxyl and amino, hydroxyl and formyl, or hydroxyl and carbonyl, or no correct answer? If you think about it, yes, it will be hydroxyl and carbonyl group. Next point, all these acids are monocarboxylic acids except what kind of acid? Is it propanoic, formic, ethanoic, phthalic? If you write the structure formula of these acids, you will find the answer. It will be phthalic acid. Next point, what kind of acid is an example of dibasic aromatic acid? Is it benzoic, phthalic, formic, oxalic acid? If you write the structure formula of this acid, my dear student, you will find the answer. It will be phthalic acid. Next point, all these compounds give effervescence with sodium bicarbonate except what? Formic acid HCOOH or benzoic acid C6H5COOH or methyl formate ester or acetic acid. My dear student, if you think about the answer, yes, it will be methyl formate, as all acids must give effervescence with sodium bicarbonate, but esters don't. Next point, toluene is oxidized by air in the presence of vanadium pentoxide and give what? Benzoic acid or phthalic acid or acetic acid or all of them. If you think about the answer and you write the chemical equation representing the reaction, you will find it is benzoic acid. Next point, esters usually have pleasant odor, therefore they are used in the manufacture of what? Artificial colors, flavors, polymers, detergents. Yes, if you think about it, yes, it will be flavors. Next point, glycine is considered from what kind of acid? Is it hydroxyl, aromatic, amino, fatty acid? If you think about it, yes, the answer it will be amino acid. Next point, insulin molecule is composed of 51 amino acids and it is considered example of what? Protein, fats, carbohydrates, oils. If you think about it, yes, it will be protein. Next point, reduction of acetic acid by hydrogen in the presence of copper chromate gives what? Copper acetate, chromium acetate, ethanol, acetaldehyde. If you think about the answer and write the chemical equation, you will find the answer it will be ethanol. Next point, chemical formula of ester obtained from the reaction of acetic acid with methanol is what? CH3COOC2H5, ethyl acetate, or CH3COOCH3 methyl acetate, or C6H5COOCH3 methyl benzoate, or HCOOCH3 methyl formate. If you write the chemical equation, you will find the answer it will be methyl acetate. Next point, all these chemical formula don't represent the esters except what? CH3OCH2COCH3 or C2H5COC2H5 or CH3OC6H5 or CH3COOC2H5. If you think about it, my dear student, you will find the answer. It will be CH3COOC2H5 as it contains COO group. Tertiary alcohols on oxidation has no oxidation occur. The reason for that, because the carbonyl group is not attached to any hydrogen atom, which can be oxidized. Alcohols and phenols react with strong metals, for example, sodium and hydrogen gas is evolved. Give reason. The reason for that, because the polarity of the hydroxyl group and the OH bond, such that when ethanol reacts with sodium, the polarity of the OH bond makes that the sodium replaces the hydrogen, forming sodium ethoxide, releasing the hydrogen gas. And also when phenol reacts with sodium, sodium replaces the hydrogen and forming sodium phenoxide and releasing hydrogen gas. So we have give reason in this point. Phenol reacts with alkalis as sodium hydroxide and named carbolic acid while alcohols don't. The reason for that, the polarity of the hydroxyl group increases in the case of phenol, due to the presence of benzene ring in phenol, which increases the length of OH bond and its weakness, and so facilitate the separation of positive hydrogen ion. My dear students, we have reached to the end of our program today. I hope you understood all different types of questions and chemical reactions that we discussed today. So till we meet again, my best wishes for you.